That is, you can start with the Vedic conception of the universe. And, of course, in the Vedic conception, the universe is created by a supreme being, by Krishna. But basically, the description in the Vedas is that the earth is considered to be at the center of a relatively small structure, and the various planets, sun and moon and so forth, are circling around the earth. And out at some distance, there's a series. Please don't do anything more with the microphones, because it's going to make that noise again. So either it works or it doesn't, but let's just leave it. So, going out to a certain distance, there's a series of shells. Actually, it's described there are 7 shells covering the universe, according to the Vedic picture. And in the Vedic literature, it's described that there are many universes existing within the causal ocean, and each one is surrounded by a series of shells like this. And these are practically innumerable. There are various descriptions given. For example, they're compared to bubbles of foam within the ocean. You can just imagine how many bubbles of foam there are in the ocean. Or they're compared to the mustard seeds in a barrel of mustard seeds and so on. Well, in other parts of the world, this same conception existed. So, in the ancient Mediterranean area, where the Greek and Roman civilizations and so on existed, people also had practically the same conception of the universe. As far as I'm aware, the idea of many universes floating within a causal ocean was not described outside of India, although maybe people did have that idea, but it just hasn't come down to us so prominently. But the ancient Greeks, for example, also had the idea of a universe which was contained within a shell. The Earth was at the center, and the different planets were moving around the Earth. So that conception was there. Now, in the Vedic literature, there's one basic description of the universe, which in the books we have is presented mainly in the 5th canto. And that describes a number of unique features, such as a universal mountain, which we call Mount Sumeru, and so on. You also find that in very ancient times, people in many parts of the world had this idea of Mount Meru. For example, the Greeks had this idea. They called it Mount Olympus. And by the time we come to the Greek civilization, they had placed it in Greece, a sort of parochial viewpoint. But the Greeks were fond of Greece, so they wanted everything to be there. So their Mount Olympus, though, really corresponds to Mount Meru, because it's a mountain on top of which the gods are dwelling. Zeus and so on lived on top of Olympus. So likewise, on top of Mount Meru, there are the dwelling places of different demigods and so forth. Also, the Scandinavians had the same idea. I once saw a map of the universe according to the ancient Norse, the Vikings and so forth. And there was a central island with a ring-shaped ocean around it, and in the center of that island there was a vast mountain. And on top of that mountain there was what they called Asgard, which is the dwelling place of the gods, with Thor and so on and so forth. So this conception of the universe used to be found all over the world. You can trace it in many different cultures. So That's one conception which was existing in ancient times, but also in ancient times there's existing the conception of the Earth as a globe and the planets as moving around the Earth in different orbits. So that's also there in Vedic literature. There are books such as the Surya Siddhanta, which describe the Earth as a globe, and they describe how the different planets orbit around the Earth. And these texts give mathematical details for calculating where the planets are at any given time. This is of interest to astrologers because they do their astrological calculations based on where the planets are within the zodiac. So these scriptures also provide rules for calculating when eclipses of the sun and moon take place. And you can do more sophisticated things. You can calculate when the sun and the moon will be at 90 degrees from one another and different things like this. So the relationship between the fifth canto type description of the universe and these descriptions of the Earth as a globe with the planets going around is the whole subject of discussion, which I can also get into. But just to give a short historical summary of what happened. As I was saying, in the ancient world, the Greeks had the same basic idea. Then, after the Greeks came the Romans, who didn't really do much in the way of astronomical investigation. They were mainly interested in politics. And then, of course, the Roman Empire collapsed, and in the Middle Ages, nobody did very much because they all became Christians. And so they weren't actually very much interested in things such as astronomy. But then came the Renaissance, which is very famous, when in Italy and also other parts of Europe, people began to rediscover the writings of the ancient Greeks. Those had been lost in Europe during the Middle Ages, but the Arabs kept them intact, more or less. Not really intact, because probably one book out of 1,000 or something like that has come down from the ancient Greeks. Yeah? Yes, the whole group, because starting with the Mohammedan conquest, the Arabian civilization extended all the way from the Sind province of India in the east to southern Spain. In fact, they actually went up as far as southern France for a while. So there were different groups, such as Moors and so forth, but they were all basically, for example, their basic language was Arabic, and of course they were all Muslims. So they had a unified culture over that vast area for quite a long time. And they kept alive the Greek culture. There are various Arabs who learned Greek and who read Plato and so on at a time when in Europe nobody was doing this. So, in the beginning of the Renaissance period, Copernicus revived the idea that the sun is the center of the universe and the planets are orbiting around the sun. There was a Greek named Aristarchus of Samos who had speculated about that in the period of Greek civilization. So, initially, all Copernicus did was shift the location of the sun, but everything else remained the same. The universe was still covered with a shell, and everything was still very close. But then, people began to consider that, well, if the planets are moving around the sun, then the fixed stars must be very far away, or else we'd see parallax. Now, when surveyors measure the distance, say, of a distant object, like the peak of a mountain, what they do is they stand in one place and measure the angle to that mountain, say, from north. And then they move over to another place and measure the angle from north. And they know the distance that they moved. So now they have one side of a triangle and two angles, so they can determine the other side. and that gives them the distance. That's called triangulation. So the change in angle when you move is called parallax. So if the Earth is on this side of the Sun at one time, and half a year later it's on the other side, then it's moved by quite a large distance. So if a star is over here, you should be able to measure how far away it is by measuring parallax. The same method. But when they made measurements like this, they'd see no change in the angle whatsoever. So this was taken to mean that the stars were very far away. Now another explanation might be that the Earth isn't moving. That's why you don't see a change. But once it's established that the Earth is going around the Sun, and it's covering such a large distance in half a year, then if you don't measure any change in angle to the stars, that means they must be so far away that you can't measure that change. So the idea became that, well, the stars must be very, very, very far away. You can calculate how far they'd have to be. It's an incredible distance. It's measured, in fact, in what they call parsecs, which is a word you'll find in the science fiction stories. A parsec, in fact, is the distance at which something would have to be so that the angular change in half a year that you would measure would be 1 second of arc. So that's several light years, in fact. So the universe became very large, and this immediately created problems because in the old system of thought, people would of course ask, well, what's beyond the shells of the universe? Well, the answer would be heaven. By heaven, they mean what we really mean by Vaikuntha. Because also in the Middle Ages and in the ancient times, it was of course believed that there was a celestial realm, what we call the heavenly planets, or Svarga Loka. The Greeks also believed in such a thing, and of course they had their demigods such as Zeus and so on. Aristotle, for example, taught that there's one kind of matter that exists on the earth, which is gross corruptible matter. It has the characteristic of decay and so forth. But once you get beyond the moon, the matter that makes up the universe is of a different character. It's what you could call celestial matter. And it doesn't have the property of decay. Everything beyond the level of the moon is perfect and eternally existing. Of course, the Greeks thought that their demigods were actually eternal. Whereas in the Vedic literature we understand that they live for vast periods of time, but they're not actually eternal. They also die. But of course in the ancient Mediterranean world, the lifespan of a Vedic demigod was so long that it would practically be eternity, because they thought in terms of thousands of years for the existence of the entire world. For example, in the Bible you hear about creation in 4004 BC. Well, back in those days that wasn't at all an unusual idea. So when the Vedic literature speak of a Manu period lasting 306 million years, or a day of Brahma lasting 4,320,000,000 years, that's practically eternity from the viewpoint of ancient Mediterranean people. So the idea then was that there was a heavenly realm. The Christians populated the different planets with angels, which are practically like demigods. If you read Dante, with his Dante's Inferno and Paradiso and so forth, you'll read that in the moon, the moon is the place where pious people who really weren't all that great spiritually, but still were pious, would go after death. So they would live in the moon. And then people who were a bit better would go to other planets, such as Venus and so forth. And then those who were really very advanced spiritually would be able to go to the Empyrean realm, which is actual heaven, which lies beyond the shell of the universe. So the idea is that people were thinking that there's this shell to the universe, and as you go out beyond the earth, you come to celestial regions of demigods, then you come to the shell, then beyond the shell is the kingdom of God. And God is there, presiding over His spiritual kingdom. So they had a place for God. It was all very believable and understandable. So After Copernicus, though, when the stars were made so far away, the shell was done away with, and the universe became a vast region of mostly empty space. Because if the stars go so far away, then mostly you simply have empty space. And so it hardly seems plausible that that could be inhabited by demigods, because it's just a huge void, basically. So, and then also, where does the kingdom of God disappear to? Because if there's no shell anymore, then there's no more room for a kingdom of God. And another thing that developed in the Renaissance was that people started applying geometry to understand nature. This wasn't done in the Middle Ages, and even the Greeks didn't really do it. The Greeks were the people who developed geometry to a large extent. This is what you'll be told if you go to school. But it's not necessarily true, by the way. For example, in the Vedic literature, there's something called Silpa Shastra, which is a practical manual for how to construct fire sacrifice altars. And it contains elaborate geometrical rules. It seems that in the Vedic period, an altar had to be constructed with very great precision. This is similar to the fact that the mantras used in the sacrifice had to be pronounced in a very precise way, or else they would not have the proper effect. So similarly, the altar had to have just exactly the right geometrical form. And so they used geometry in order to construct these forms. So they had all kinds of geometrical rules whereby you could construct different triangles and circles and so on in an appropriate way. For example, the altar might have a very elaborate shape, like the shape of a large bird. But the area had to be precisely fixed. So how do you build a bird-shaped structure with the right angles and so on, which has a given area? And then for a more elaborate sacrifice, you may have to multiply the area by 2. So if you multiply the area by 2, how do you change your construction so that it has the right shape, but now twice the area? So they could solve all those problems, and they used geometry to do it. For example, the Silpa Shastra uses the Pythagorean theorem, which says that if you have a right triangle, the sum of the squares on the sides equals the square on the hypotenuse. And they had it in general form also, not just in specific cases. So, the interesting thing is that in the Silpa Shastra, though, no formal discussion of geometry is given. It just uses geometry. So somewhere else there must have been a discussion of all the basis of geometry, but that literature no longer exists. At least nobody seems to have it. Because many things also have been lost in India. So, over the course of years with different invasions and so forth. So the Greeks had developed geometry, and everyone has heard of Euclid. Euclid wrote a systematic treatise on geometry, and that became the standard for the study of geometry. So, in the old days, though, even in the days of the Greeks, the tendency was to use geometry as a practical tool. Just as in the Silpa Shastra it was used for practical purposes of building altars. However, the Pythagoreans had a different idea. They were thinking that somehow geometry is the basis of reality. And geometry can be based on numbers. So ultimately numbers are the basis of everything that's real and that exists. So in the Renaissance, this idea was revived. But the people in Europe in the Renaissance really took this up wholeheartedly, whereas previously that hadn't really been done. Because previously people were thinking that the ultimate basis of reality is something spiritual. And there's no way that you can discuss something spiritual using geometry. How can you explain God in terms of triangles and circles and so forth? And people were thinking that there's a reality to mind. Mind really exists. In fact, mind is more important than matter. This is how people used to think. But you can't understand mind in terms of mathematics. That, in fact, has been the history of modern science. No one has been able to understand mind in terms of mathematics. So in modern science, the tendency is to say, well, there's no such thing as mind. It doesn't exist. So this idea of explaining everything in terms of mathematics became established. So then Euclidean geometry became the model for the universe. So in Euclidean geometry, there's space that goes to infinity. There's no limit to it. It's simply infinite. And you can imagine little stars scattered throughout space, going out to infinity. So this became the picture which developed. So this leaves no room at all for God as a personal being ruling a kingdom somewhere. Because where are you going to put God? If reality consists just of Euclidean space going out to infinity with no limit, then there's no place for God. But of course, people already had many impersonal conceptions of God. So you can imagine God as some kind of all-pervading spirit which cannot be visualized as having any kind of personal form. And you can say that the naive, common people may think that God is an old man with a beard sitting on a throne somewhere, but we know that actually God is an indescribable spirit. And also, some philosophers began to develop the idea that God really is geometry. And in fact, Isaac Newton took up that idea. Because Isaac Newton believed in God. He had to, because in those days, if you didn't, you were in real trouble. They'd burn you at the stake. But Newton had the idea that, well, space is the sense organ of God, just as we have our senses like eyes, ears, and so forth. So Newton thought that Euclidean geometrical three-dimensional space is God's sense organ. So naturally God is all-pervading and he sees everything because space is everywhere. So he essentially identified God as space. The idea was that then space is conscious and it can see and feel and so forth. And so therefore, and God is space, so therefore God knows everything. That was Newton's idea. So you see, by the way, what it means when it said that Newton believed in God. One has to be a little bit careful. It's not that he believed in Krishna or had any such conception. So the idea then was that the universe is Euclidean space and stars are scattered throughout space going out to infinity. Then there came Olber's paradox. And Olber's paradox, and by the way, in this picture, the solar system with the Earth and so on is totally insignificant. It's just like a speck in a vast void. So this led to a very materialistic picture of things. Then came Newton, who gave mathematical formulas saying how the planets move. And this eliminated the need for an intelligent being to be controlling the planets, because it should also be pointed out that in the Middle Ages, the people were thinking that the planets were guided by angels. Even Kepler, the astronomer, had the idea that there was an angel behind each planet, or sort of within the planet, and that angel was moving the planet. Well, of course, that corresponds exactly to the Vedic idea, because according to the Vedic conception, there are planetary demigods. That is, the graha, or planet, in the Vedic conception, is really the demigod. For example, in the description of the churning of the milk ocean, we find the sun and the moon sitting down together to drink this nectar. And then Rahu sits down next to them because he wants to drink it too. And so on. So the planets were regarded actually as personalities. And also there's a personality of the earth, namely Bhumi. So that idea was also there in ancient times in Europe, and even Kepler still believed that. But after Newton, that whole idea was regarded as, of course, being totally outmoded and ridiculous, a product of past superstition. So there were no more angels moving the planets. So the solar system became a tiny little mechanical clockwork in which planets were spinning around the sun, but this was just a speck in an infinite void, populated by other similar specks, in which you might also have planets circling around other stars and so forth. And by the way, when the stars were moved so far away, that's when they became suns. This is the distinction between the Vedic and the modern Western picture of things. In the Vedic literature, it is not said that the stars are like individual suns. They're more like planets reflecting light. But if the stars are so far away, as the people were now believing, then they have to be very bright so that they can be bright enough for us to see them. That means they have to be suns. And if they're also suns, then they can have planets and so on, and the whole realm of science fiction then is opened up. So, but then some people came up with what is called Olber's paradox. And that is that if you have stars scattered through space going out to infinity, you take a shell of radius r, the surface goes up as 4 pi r squared. The intensity of light from one star goes down inversely with the square of the distance. The number of stars on the shell should be proportional to its area. That means each shell should contribute about the same amount of light on the average. If there are infinitely many shells going out, that means we should be getting an infinite amount of light. That means it shouldn't be dark at night. Rather, there should be infinitely intense light striking us at all times, which means that there would be infinite temperature and we couldn't even exist. So, what that meant was this picture of the universe extending out to infinity in this way was impossible. Such a thing could not be, at least according to their idea of how light operates. And that includes the inverse square law and so on. So, this began to sink into people's minds, and various attempts were made to get around it, and nobody could do it. So finally, people began experimenting again with the idea of a finite universe. And so Einstein came up with the idea of curved space. He threw out Euclidean geometry, and he introduced non-Euclidean geometry. And the basic idea of non-Euclidean geometry is that space itself curves. To make an analogy to this, in 2 dimensions, the surface of the Earth is a globe, and that curves in on itself, so that the total surface of the Earth is finite, even though there's no edge anywhere. So you can have a finite surface, but it doesn't have an edge if it curves in on itself in the form of a sphere. So some mathematicians thought, well, you can do this with 2 dimensions if you curve it within 3 dimensions, as with the surface of a sphere. And then they said, well, we don't even need the 3rd dimension, because mathematically we can describe the surface in terms of the local relation between the points on the surface, and we don't even need the 3rd dimension that we embedded in. That's just useful for imagining how it curves in on itself. So they said, well, we could do the same thing in 3 dimensions, or n dimensions in general. So you could imagine space like 3-dimensional space that curves in on itself, so that there's no boundary anywhere, but there's a total finite volume. So mathematicians just toyed with this, just as part of their own fun and games. A fellow named Riemann developed it in detail. So Einstein used this to provide a model of the universe which now was finite instead of being infinite. But there were no edges, so there's no shell to the universe. So he proposed that model. But he thought of the universe as being fixed and static, which was also an ancient idea. That nothing is really changing out there. Things remain the same for very, very long periods of time. So a fellow named Friedman discovered that according to Einstein, the universe really should be expanding. It's because his model was unstable. It wouldn't just stay fixed. It would expand like compress it, it gets warmer. For example, if you take gas in a cylinder and compress it, the temperature goes up. So if all the matter in the universe was compressed into one small region sometime in the past, then it must have been very hot. So, in fact, it must have had a temperature of millions and millions of degrees, you can calculate. So that means this explosion involved intense heat, and everything was in the form of just particles bouncing against one another. Even atoms could not hold together under this intense heat. So people speculated like that. Yeah? Well, the idea of the atomic bomb developed at about the same time. That was another development, however. But that happened because they were studying atoms and subatomic particles and so forth.
That was connected with the small, very intense. So when it expands, gives off a lot of heat.
Well, of course, an atomic bomb is an explosion. But there the idea is that you're releasing energy which is already stored up in the matter. And when the energy is released, the thing explodes. But the Big Bang was a different kind of explosion. Because in Einstein's theory, you see, another thing about the situation is that as you go back, the contraction going backwards in time proceeds right down to a point. Mathematically, this is what happens in Einstein's scheme. It's not that you go down to something very small, and that's the starting situation. But actually, you go right down to a point. Which means now going forwards in time, you start with a point, and the universe has to come out of a point. Now, this immediately is a problem with this whole theory, because starting with a point, why do you ever have anything but a point? Why should a point create a universe? After all, supposedly there are lots of points around. Here's a point. Here's another one. So why doesn't that generate a universe? So no one can explain why a point should generate a universe. So in the early days of the Big Bang theory, the customary response was to say, well, now we have gone beyond the realm of science and entered the realm of metaphysics. Or scientists would just say, well, I won't speculate about that. That's a common answer. Which is a little ironic because they've been speculating like anything to come up with this whole theory. And then when there's a problem with it, they say, I do not indulge in speculation upon such topics. So, back in the 30s or thereabouts, that was the standard answer that they would give. So, and also in those days there was a competing theory known as the steady state theory. This is an amusing theory. According to this one, the universe is infinite and expanding. Well, if it's infinite and expanding, everything's moving away from everything else. But according to this, matter appears out of nowhere in the intervening space. And this just happens. Because if you can postulate one thing, you can postulate another. So why not postulate matter coming out of nothing? May as well. So, after all, if you're going to postulate the universe coming out of a point, why is it bad to postulate a little bit of matter coming out of a void? So according to this theory, the universe is expanding and matter is popping out of the void and providing new galaxies to fill up the space. And it all balances out so that the thing is in a steady state. As the galaxies get further apart, new galaxies appear, so you always have the same number of galaxies in any volume. So that was the model invented by Fred Hoyle and his collaborators. But that model got kicked out. And Fred Hoyle became a renegade. And now, Fred Hoyle has hidden out in the mountains of Wales somewhere, and his address is not even available. But then that's because of other infractions that he committed in the scientific realm. So practically they tarred and feathered him and drove him out. In England, traditionally, whenever anybody became a renegade, he'd hide out in the mountains of Wales somewhere. people used to do that to avoid being burnt at the stake, in fact. But so Fred Hoyle's hiding out. Of course, he committed other crimes. Fred Hoyle finally became a creationist. He argued that God created everything. And for a scientist to do that is the ultimate heresy. And then even worse, he did things like argue that interstellar space is full of things like bacteria, which was considered to be a very bizarre thing for a scientist to propose. And then he even went so far as to give evidence for it, which was almost worse. So, if you mention the name of Fred Hoyle to a scientist these days, he'll immediately start cursing, because everybody's learned the word on Hoyle. So, the steady state theory is out. So, the Big Bang theory was considered to be somewhat speculative, though, up until a few years ago. And a few years back, it seems that some scientists named Penzias and Wilson, who worked for Bell Labs, were directing a radio telescope to various directions in the sky, and they picked up this dim hissing sound, meaning that radiation was coming in at a certain wavelength. And they couldn't figure out what the source of it was, because it was of the same intensity in every direction. So it didn't seem to come from any obvious stars or planets or galaxies or anything like that. And originally they thought their equipment may be just producing the hiss, but they checked all the equipment and nothing seemed to be wrong. So then some other people said, well, if the universe began with a Big Bang and there was intense heat in the beginning, then there was intense radiation propagating in all directions. So as the universe expanded, this radiation gradually became dimmer and dimmer. It's just like when an explosion goes off. First you see this burst of light, and then it fades out. So the idea was there must have been this radiation that over all these years since the original explosion has been fading out. But still it should be there with a certain intensity. And so they calculated that it would have a very, very low intensity. And it should be the same in all directions, because the explosion is completely uniform according to this theory. So, these people said, aha, the hiss that Penzias and Wilson are picking up in all directions must be that original primordial radiation from the Big Bang. And they said, aha, that proves it. That conclusively demonstrates that the universe did come about by a Big Bang. Well, that was their reasoning. So, that may seem a little tenuous. But what happened then was what you could call the Big Bang bandwagon got started up. And it became established that you have to believe now in the Big Bang. Because how else could we explain that radiation? So, the steady state theory was completely repudiated, and the Big Bang theory was established. And since then, it has become the established dogma. Now, this is a phenomenon that tends to happen in science. In science, what will happen is that a given theory may be rejected for years, and it doesn't matter what evidence is in favor of that theory. It's just rejected. But then at a certain point, a sudden flip-flop will occur, and the theory will be established as truth. Everyone will accept it. And the evidence that used to be rejected as being totally inconsequential is now accepted as proof that the theory is true. So that happened with the Big Bang theory, because the Big Bang theory really got started back in the 30s or thereabouts. And in the late 40s, George Gamow predicted that all the different elements in the periodic table could have been synthesized in the Big Bang. But then later on people realized that mathematically that wouldn't work out anyway. So you had to have some other explanation for where the elements came from. So up until the 60s, the Big Bang wasn't accepted. But then when this discovery of the so-called cosmic black body radiation was made, that did it. And everyone flipped over and began accepting the Big Bang. So now it's accepted practically as the gospel truth. And if you talk to scientists, you'll find that they take it for granted. They just regard that as, accepted. It's not even open to question. So, of course, in science, you'll also be told by scientists that in science we never prove anything. We always merely consider tentative hypotheses. This is supposedly what scientists do. That's the creed. But at the same time, you'll find, so therefore a scientist really shouldn't believe something like the Big Bang Theory. He should just consider, we don't really know, but this is a tentative hypothesis. But what you find is that people, being people, have to believe something. It's actually human nature to believe something about the world. And so, the scientists are no exception to this. So they also have to believe something about what's really there in the world. So nowadays, the tendency is to believe the Big Bang Theory. There are a few scientists who don't accept it, but they're considered to be eccentrics nowadays, and there are just a few of them, a handful, essentially. So everyone else is riding on the Big Bang bandwagon. So that's a historical account of how this all came about. Now you can see essentially from that what our task is, or what we're trying to do essentially, because we're trying to take this whole process and go all the way back to the original Vedic conception of the universe, which I started the description with. So essentially, that's like reversing the whole course of history as it's taken place over the last 300 years or more. We want to go, it's like saying we're going back to the Middle Ages. So people will tend to think that that is the most ignorant and backwards and completely useless thing you could possibly want to do. It means throwing out all scientific progress and going back to the age of superstition, when people still thought that angels were moving the planets around. But that's what we're saying. So you can see the task which we're confronting. And of course we actually have to confront it. Basically our tendency is to really not discuss these things. But there's no way around it if we want to solidly establish Krishna consciousness. And Srila Prabhupada was, of course, very well aware of this. And that's why he wanted the Bhaktivedanta Institute to carry out this program. And I should mention here that, as you know, Srila Prabhupada wanted to create a transcendental city in Mayapur. And in the center of this transcendental city, which will be one of the wonders of the world and will attract the attention of people all over the world, in the center of this city, there's supposed to be a huge temple called the Temple of Understanding. So the idea is that this temple will be the center of all spiritual, metaphysical, and physical understanding of the nature of reality. And all the different creeds and conflicting views that people have can be reconciled by the Vedic understanding which will be presented in this Mayapur center. And in the middle of that temple, Srila Prabhupada wanted a model of the universe according to the Vedic description. That means that this model of the universe will be the very center of attention for the entire world. That means that Srila Prabhupada was putting a model of the universe according to the 5th canto at the center of the preaching effort of the Krishna consciousness movement. So one should consider what the implications of that are. That means we can't avoid it if we want to carry out that instruction. There's no way we can just go on and preach and think that, well, we'll just leave this aside because only a few questions come up now and then, and, well, we won't put much emphasis on it. At least we can't do that if we carry out this instruction. Well, it's getting late again. We'll have further additions to this class. Any questions or comments? Yeah? Yeah, that's an important point. In Einstein's conception, space curves in on itself. So what is outside of the curve? Well, nothing. It's not even imaginable. All of space is just this closed, curved continuum. And there's no outside. You can't even get outside, because wherever you go, you just go around the curved continuum. There's no way out, and there's no outside. So all of space is this closed continuum. And as you go back and back, it gets smaller and smaller. And when you go right back to the initial point, there's no more space. That means nothing exists. It's not that there's a void, and a point in the void explodes and fills up the void with the universe. That's not the conception. The conception is that there's nothing. Literally nothing. Not even space. So that's the conception in the Big Bang Theory. Yeah? Yeah. Yeah, but you can see what that means. That means as the Earth is going around like this, in its orbit, all the stars have to be going along like that too. That's a pretty implausible picture of things. Why would they be doing that? Moving just in the same way that the Earth moves. So, no one ever seriously proposed that as an explanation. Of course, there's another way of looking at that, by the way. If, as the Earth goes around in a circle, all the stars are going around in a circle too, that means, in effect, all of reality is going around in the same circle, so why not just say that that's standing still, including the Earth, and the Sun is going around the Earth instead? You see what I mean? Because you're saying the Sun is standing still, and so to speak, the whole universe is executing a circular movement like this. But you see, that may be that they had crude instruments. But even if you can only measure angles crudely, it still means that the stars have to be very, very far away. For example, the Moon occupies 1/2 a degree of arc in the sky. And we know how large the Moon looks when it first comes up over the horizon. This was observed last night. So that's 1/2 a degree. So you can measure distant angular differences of less than 1/2 a degree, even using a crude instrument made out of wooden beams and so forth. For example, Tycho Brahe, the Danish astronomer, built very large devices in which a wooden beam moves on a hinge, and you sight along a line at a star using the eye, and then you have a calibrated arrangement like a protractor in which you measure the angles. So he used this method of measuring angles to things. Well, you can come within a fraction of a degree with that easily enough. So if there's no movement of that size, still the stars have to be very far away, because the distance traveled by the Earth in half a year is twice the distance to the Sun, and that's a very large distance. So it means the stars have to be many, many times that distance in order for the triangle with that as the base to have such a fine point. So, yeah?
You were talking
Well, I have contact with various scientists. Basically, what I'm trying to present to them, though, is simply the more fundamental point that life is not material. And that consciousness is a non-physical reality which can influence what matter is doing. And also provide for the idea of the supersoul. That is, two kinds of consciousness, individual consciousness and the supreme consciousness. So this is, these are very basic points. I haven't tried to discuss cosmology with the scientists yet. We have, in order to do that successfully, we have to establish a much more solid foundation than we have right now. We have certain basic points that we can make. But essentially, you see, in this magazine, all we do is criticize the basic Big Bang model. Now notice what we're doing. They say the Big Bang occurred billions of years ago, about 20 billion to be exact, or 16 billion. They change it all the time. And they're talking, and it involves observing things at very large distances, going out to, well, they'll say 10 billion light years for quasars and things like that. So we're criticizing them at that level of speculation and saying, well, really, this is pretty much baseless. Just see how they're speculating in various ways and look at the different contradictions here. What need is there really to accept this? That's one basic point we make there, because Srila Prabhupada wanted us to refute their speculative arguments and show that it's all just speculation. So we're starting with the most speculative things that they're saying. Now, another thing you might discuss is the argument that the stars are really so far away. But that's coming much closer to home. And another thing you might discuss is the heliocentric theory itself, how the sun and the moon are operating and so on. And then going even further, you can come to the point of discussing Mount Meru and questions like that. So, with each step you take in that direction, what you're saying becomes more and more unbelievable to a person with scientific background. So we have to establish a more and more solid presentation. Actually, many things can be done to establish this. It's not that it's a hopeless thing. Now, we took one step in that direction in this article. Although it's not pointed out explicitly why we took this step. Nonetheless, in setting up this magazine, we're planning for the future. So we discussed such things as the fact that in the quantum theory, one interpretation of quantum mechanics is that there are multiple parallel universes that are invisible to us. That's what this diagram shows here. The runner splits into multiple runners in multiple universes, and they all have different histories. Some scientists are seriously proposing such a thing in the quantum theory. So we're pointing out that they're seriously talking about the idea that there can be whole realities with people and so on and so forth that are coexisting with us and we can't see them. And they also make that point in a different way with their idea of missing mass. We illustrate here the concept that the galaxies that we see represent only a fraction of the mass of the universe, and there's a vast realm of mass, maybe 99% of it, which we can't see or detect in any way. There are reasons why they propose such a thing. So lately, they've been talking about that at great length. So that's another indication of how they're thinking that it's possible that there can be invisible worlds, which we can't pick up with our senses. They're even speculating that in this invisible matter, the matter could also be organized in the form of planets and living beings and so on. What is the point here? What we want to argue is the basic point is the scientists themselves are considering the possibility that there could be invisible realms in which things are going on that we can't see. Well, in the Vedic literature, that is the very thing that is described in great detail. We certainly can't see Mount Meru. We can't see the ocean of milk. We don't even know where you would look. Say you have say you go to Mount Palomar and you have an opportunity to use their telescope there for a few hours. Let's say you want to see Mount Meru. Which way do you point the telescope? Do you have any hope of seeing it that way? It's absolutely out of the question. So, actually, this Mount Meru is supersensual, you could say. We can't pick it up with the senses we have. So, someone may say, well, this is certainly bizarre superstition. How can you believe in all these things that you can't see? Isn't this absurd? But we wanted to make the point here that the scientists themselves are proposing such things. Of course, they're doing it in their own speculative way, but they're also proposing such things. So if the Vedic literature proposes such things, then what's wrong with that? In fact, another point can be made that if, in fact, there are realms of existence that you can't pick up with your senses, then you can't really hope to use the empirical method to understand these realms of existence, simply because you can't pick them up with your senses. But using the descending process, which is the basis of Krishna conscious philosophy, you can hope to find out about such things. At least in principle, you can see that it's possible to do that by the descending process. So, this idea of invisible realms of existence fits in with our basic picture of things, and not with the scientist's picture. So that's one basic point we wanted to make here. And I should point out another thing that can be done with the, as far as this whole subject is concerned, is examining various empirical things that don't fit their theories. And there are many things like that that actually are observed. So I'd better end there. All glories to Srila Prabhupada.